All right, here we go. Half angle identities. So again, note card, get out your note card. It should be out. But now we're doing half angle identities. So the sine of 1/2 x equals, depending on what quadrant you're in, positive or negative, 1 minus the cosine of x over 2. For the cosine of 1/2 x, it's the exact same formula with a plus in the numerator. And then we have 3 tangent formulas. Now we know the tangent is sine over cosine, so it's basically the sine formula over the cosine formula. But we have two much simpler formulas than that. One is sine of x over 1 plus cosine of x. And the other one is 1 minus cosine of x over sine of x. I prefer the last one, if you want to know. That's the one I prefer to use. So on a section of your note cards, you should have half angle identities.
Okay, so the third one. I get that. I was confused. Yeah, I'm also confused by miles. Don't worry. Wait, here's Bob. How does that first term one make sense? Because wouldn't that just equal a plus or minus 1?
Don't you see that plus sign in your denominator?
Sorry.
Miles, you didn't need to apologize because I forgot the plus sign in the denominator.
I know I should have rolled with that.
Yeah. Okay. So let's say we have the sine of 67.5 degrees. Okay, you can't just look on your note card and know what. I mean, you can't just look at the unit circle and figure out what the sine of 67.5 degrees is. So you're going to have to use a half angle identity. 67.5 degrees is 1/2 of what? 135 degrees. Okay. How do we figure that out? Well, you just take 2 times 67.5 to figure out what it is. Okay. Not that hard. So the formula. Well, where is 67.5 degrees at? What quadrant? 1. So sine is positive in the first quadrant, so your answer is positive. So you don't do the plus or negative in front because you know it's going to be positive because it's in the first quadrant. So you go 1 minus the cosine of 135 degrees all over 2. Well, what's the cosine of 135 degrees? And this is where it gets complicated. Looks like we have a complex fraction inside of our radical. Oh, no. Complex fractions, radicals. Oh. What's minus a negative? Plus a positive. What do we do to the top and bottom? Multiply by 2. So, if I distribute my 2 on the top, I get the square root of 2 plus the square root of 2 over 2 times 2, which is just square root of 2. On the bottom, what's 2 times 2? 4. What's the square root of 4? 2. So it's the square root of 2 plus the square root of 2 all over 2. And this is how we're going to leave our answer, a radical within a radical. I know that's odd to look at. You haven't seen those in the past, but this is a radical within a situation where we leave a radical within a radical, which is kind of a radical concept. Oh, all right, Bebach. All right. Tangent of negative 15 degrees is a tangent of 1/2 of what? Negative 30 degrees. Which tangent do I like to use? The bottom one, which is 1 minus the cosine of negative 30 degrees over the sine of negative 30 degrees. What's the cosine of negative 30 degrees? Positive square root of 3 over 2. The denominator is negative 1/2 because we're going negative 30 degrees. So it's really at 330 degrees on your unit circle. So how can I get rid of my negative 1/2 on the front on the bottom? Multiply both the top and bottom by negative 2. What's negative 2 times 1? Negative 2 minus negative 2 square root of 3 over 2, right? Minus a negative is plus a positive. The 2's cancel, so we get negative 2 plus square root of 3. Now, kids, is there a way to check our answer? Plug it into your calculator. Make sure you're on degree mode now because we're talking about degrees. And you go tangent of negative 15 degrees, and you get an answer. And you go negative 2 plus the square root of 3. Whoops. Square root of 3. And they match. If they match, you're good. Okay? You want to see a couple more examples, or are you good to go with that?
No, we're good.
Are you sure?
Yeah.
Okay. So if you're good, we are going to do 9 through 15, or is it 17? I don't remember what I assigned Abby Palmquist. No, I can look that up, but no, it's probably 17. But we'll just do 9 through 15, the odds, and Abby can be crabby at me if she's already done it.